Hey guys, today I have brought some selected and conceptual problems on probability. If you are new for my YouTube channel, like and subscribe so that you will be a family of Maths Academy too. So let me take you to the problems. The first question is, a 3-digit library identification card is to be printed from numbers 0 up to 5 in a way that the first digit is non-zero and no number is to be repeated. So using this information, how many cards can be prepared by making the first non-zero and not repeating any digits from 0 up to 5? So here I will show you two different ways of finding the answer for this problem. We are going to use 3-digit number. Okay, so we use 3-digit number. In the first place, we will not use 0, but we will have 5 possibilities. There are 5 possibilities, but it's possible to use 0 in the second and in the third position. So if we use 5 different numbers in the first position, we will have another 5 possibilities in the second position, including 0, and not repeating what we used in the first place. Then in the third position, we will have 4 different digits. There are 4 possibilities. So we use the product of 5 times, using product rule, 5 times 5 times 4, which is 100. So we can prepare 100 cards by not making the first digit 0 and by not repeating any of the digits from 0 up to 5. This is one way. The other way is use the numbers 0 up to 5. Now, whenever we want to prepare an ID card with the first number non-zero, assume this first column is the possible numbers that we use in the first digit. Here are the numbers that we use in the middle, and the third column is here. So we can use 0 in the second and in the third place. So the other thing is no digit will be repeated. For example, we can't use 1 0 0. 0 should not be repeated according to the information. So we can't also take 0 1 1. Okay, 1 0 1 will not be taken. Here 1 should not be repeated according to the information, but we can form number 1 0 2 is possible. This is possible. This is possible. 1 0 3. Here no numbers are repeated. 1 0 4 and 1 0 5. This is one possible ways of arranging the numbers. We can have also another possibilities. For example, if we take 1 2 1 2 0, okay, 1 2 3, 1 2 4, 1 2 5. Here, by fixing 1 and 2, we can have 4 numbers, but by fixing 1 and 0, we can have 4 numbers. Now again, fix 1 with 3. Fix 1 with 3. Let me use different colors. So let's fix 1 with 3. Then we will get, let's fix 1 with 3. Then it's possible to take 0 1 3 0, 1 3 2 is possible, 1 3 4 is possible, 1 3 5 is possible. Here, by fixing 1 and 3, we will have another 4 numbers, ID numbers. Again, take 1 with 4. 1 with 4, then 1 4 0 is possible, 1 4 0 is possible, 1 4 2, 1 4 3, then 1 4 5. Again, 4 different ID numbers. Still, I'm continuing fixing 1 and use numbers. So let me take 1 with 5, then take 5 to 0, 1 5 0, 1 5 2, 1 5 3, 1 5 4. You see, without changing the number 1, by fixing 1, we can have 4 plus 4 plus 4 plus 4 plus 4. We can have, by fixing 1, we can have 20 ID numbers. Again, you can fix 2 and you will have 20 different ID numbers. Fix 3 on the first, okay? Fix 3, then you will have 20. Fix 4, you will have another 20. Fix 5, you will have another 20 ID numbers. By fixing all these first numbers, you can have this 20 plus 20 plus 20 plus 20, totally 100. Different ID numbers can be formed by not making the first digit 0 and by not repeating any of this digit. Actually, this way of answering such problem is time taking. I don't recommend you to use this technique. So I need you to use the first method that I have shown you here. This is preferred. It's only applying the rules. Therefore, the answer for this problem is A. A student needs to select 3 books from 3 mathematics, 3 physics, and 1 history books. Totally, there are 7 books, and a student needs 3 books. What is the probability that one of this is mathematics and the other 2 are either physics or history? So to calculate this probability, we need to put the given information mathematically. So totally there are 7 books. Out of 7 books, the student needs to select 3 books. Okay, what kind of books? He will select 1 mathematics book out of the 3, and the other 2 are either physics or history. So he can select 1 from physics and 1 from history. Okay, totally he will select. So this is one option. The other option is he will select 1 mathematics book and the other 2 are either physics or history. Means the other option is he can take 2 physics and no more history. Generally, he will select 3 books. So these are the possibilities that he can select. So the probability of selecting this thing is combination of 3,1 times combination of 3,1 times combination of 1 over the sample space 7,3. The sample space or the total possibility set is combination of 7,3 plus combination of 3,1 times combination of 3,2 times combination of 1,0 over the sample space. So these are the 2 possibilities in this probability. So you need to be familiar with combination. A combination is defined as combination of n object with R selection is defined by n factorial over n minus R factorial times R factorial. So, for example, if you want to calculate combination of 3, 1, you can do like this: 3 factorial over 3 minus 1 factorial times 1 factorial. And to remind you what factorial is mean, for example, if you want to calculate 3 factorial means 3 times 2 times 1. 5 factorial means 5 times 4 times 3 times 2 times 1, nothing more. So this is the factorial. So it's very simple calculation. So apply this definition of combination. So combination of 3, 1. Combination of 3, 1 means 3. You can calculate using this formula. Okay. Combination of 3, 1 is 3 times combination of 3, 1 here is 3 times combination of 1, 1 is 1 over combination of 7, 3. You can check that combination of 7, 3 is combination of 7, 3 is 7 factorial over 7 minus 3 means 4 factorial times 3 factorial, which is 7 times 6 times 5 times 4 factorial, 4 factorial over 4 factorial times 3 factorial. 3 factorial is 6. 4 factorial can be cancelled out. So this 3 factorial will be cancelled by 6. So 7 times 5 is 35. So combination of 7, 3 is 35 plus here 3 times combination of 3, 2 is also 3. Combination of 1, 0 is 1 over 35. This result is 9 over 35 plus 9 over 35, which is 18 over 35. Therefore, the probability of selecting one mathematics and the other two are either physics or history book is 18 by 35. Therefore, the answer for this problem is D. How many 4-digit even numbers can be formed from the numbers 1 up to 5 if the number starts with 3? Okay, here the question is how many 4-digit even number can be formed using these numbers 1 up to 5. Okay, so ideally the numbers will look like this. 3, you can use anything in between, and the unit digit should be 2, or the other option is 3, any number 1 up to 5 in between, and the unit should be 4, because the question is 4-digit even number. So it becomes even number whenever the unit digit is 2 or 4. But in between this number, in between this number, here you can use any number 1 up to 5. You can use any number 1 up to 5. Similarly, the same thing here. So this is the calculation. We have 1 possibilities in the unit digit, 5 possibilities in the second digit, 5 possibilities in the third, and in the last we will have only 2 possibilities, this one and this one. So the product of this thing will be 50. Okay, so there are 50 4-digit even numbers which can be constructed by a number 1 up to 5. Therefore, the answer for this is B. A committee consisting of 3 students is to be selected from 10 candidates, among which 4 are girls. What is the probability that at least 1 girl is selected? Here here there are a total of 10 candidates. We use the concept of combination to calculate this probability. Order doesn't matter here. We use combination. Totally, we do have 10 candidates. Out of these 10, we want to select 3 committee members, but the committee members will be selected in order to have at least 1 girls. Okay, so basically there are 4 girls in this 10 group. The rest 6 are boys. So out of these 4 girls, at least 1 girl will be selected. If we take 1 girl out of these 4, the rest 2 will be from boys. Okay. The other option is at least 1 girl means you can have the right to select 2 girls. Okay, you can have also the right to select 2 girls by selecting only 1. You can have also the right to select 3 girls out of these 4 by not taking any boys. Okay, so this expression is the meaning of at least one girl in order to have 1 girl in the committee. So this is the possibilities. So we take this number and divide by the combination of 10, 3. Now I will show you how you can calculate combination of 10, 3, which is by definition 10 factorial over 10 minus 3 factorial times 3 factorial, which is 10 times 9 times 8 times 7 factorial over 7 factorial times 3 factorial. Now we have something that can be cancelled. 3 factorial means 6. So this is 10 times 9 times 8 over 6 by 3, 3 by 3, 2 by 2, 4 by 2, 1. Therefore, this number is 120. 3 times 4 times 10 is 120. Combination of 10, 3 is 120. Similarly, you can calculate the combination of all these things. Okay, for now, to save the time, I will just tell you the numbers, the values that each of this combination is. So combination of 4, 1 means 4, and combination of 6, 2 means 15 plus combination of 4, 2 is combination of 4, 2 means 6, and combination of 6, 1 is also 6, plus combination of 4, 3 is 4, and combination of 6, 0 is 1, over the combination of 10, 3, which is 120. So this result is 60 plus 36 plus 4 over 120, which is 100 over 120. So you can simplify this thing. 10 over 12 or 5 over 6 will be the probability of selecting at least 1 girl in the given committee. So our answer will be A. A company produced 25,000 bulbs and randomly tested 2% of the product. A certain company produces 25,000 bulbs and randomly tested 2% of the product. Among the tested bulbs, 40 have defect D1, 60 have another defect D2, and 25 have both types of defects. Then what is the probability that a bulb produced by the company has none of the defects? So let us take first how much of this product is tested. 2% of the product, 25,000, is how much? That means 2 over 100 times 25,000 means this is for 500. Okay, so they just tested 500 bulbs. Okay, out of these 500 bulbs, 40 have defect D1. Okay, 40 have defect D1, and 60 of these bulbs have defect D2, and 25 of these bulbs have both defects. Okay, so you can use the formula for set theory. So the number of bulbs having defect D1 or D2 is the same as the number of bulbs in having defect D1 plus the number of bulbs having defect D2 minus the number of bulbs having both defects. Okay, having both defects. So this is 60 plus 40 minus 25. The result is 75. So out of these 500 tested bulbs, 75 of the bulbs have defect D1 or D2 or both. That means 425 bulbs has no defect. Okay, out of the 500, 75 have defect D1 or D2 or both, meaning that 425 bulbs are normal, they are defect free. So the question is, what is the probability that a bulb produced by a company has none of the defects? So out of 500, 425 are normal. Okay, out of 500, this is normal. So you can simplify this thing by 5, 85 by 5, it's 100. 85 over 100 means 0.85. So the probability of obtaining a bulb which is defect free is 0.85. So the answer for this problem is C. If S is a set with 10 elements, and A is the subset of S, what is the probability that A has 3 or more elements? So to make things clear, you can represent this S by something. Say S contains 10 elements, or you can mention in this way, okay, up to 10, and A is the subset of S. So A can have the right to be empty set. A can be empty set. A can be a set containing only 1. A can be a set containing 1 and 2, any single element. Okay. A can be a set containing 3 elements, any 3 elements from the set. Okay, it should not be necessarily 1 to 3. A can be a set containing only number 8, but here you can have these different ways to describe A. Okay, so you can assume A up to the set S itself. A can have the right to be S itself because every set is a subset of itself. So the question is, what is the probability that A has 3 or more elements? So we ignore this part, and this part. Okay, totally there are 11 conditions, including empty set. So we ignore the first three things because the question is, what is the probability that A has 3 or more elements? So 3 or more elements means we ignore this part, the first 3 part, and we take the possibilities of the rest. There are 8 other possibilities for A to have 3 or more elements out of the 11. Okay, so 8 over 11 is the probability that A has 3 or more elements. So 8 over 11 will be the answer. Different codes, each of which consisting of 5 characters, are to be generated in such a way that the first 2 characters are any of the English alphabet. The first 2 characters are from any of this A up to Z, and the remaining 3 are any of these digits. How many distinct codes can be constructed or generated? Okay, so here is the possibilities. Okay, there are 26 English letters. So we want to make distinct codes using this A up to Z on the first 2 characters and 0 up to 9 on the next 3 characters. So if we want to make it distinct, we will have 26 possibilities on the first. Then you will have 25 to make it distinct. Then the rest are numbers. Okay, we use 10 numbers on the third position and 9 in the fourth and 8. Otherwise it will not be distinct. So the product of all these things becomes the number of distinct codes that can be generated from English letters on the first 2, then the next 3 from digits 0 up to 9. So whenever you calculate the product of this number, you will get 468,000. Okay, so the answer for this problem is A. Items produced by a certain company are subjected to 2 kinds of defects, D1 and D2. This question is almost similar with question number 6. You can, if you understand that number 6, you can easily solve this one. So items produced by a certain company are subjected to 2 kinds of defects, D1 and D2. Out of the total product, 5% have defect D1 and 10% have defect D2, 2% have both defects. So let us put this thing mathematically. Okay, the number of items having defect D1 or defect D2 is calculated by using set theory. The number of items having defect D1 plus the number of items having defect D2 minus the number of items having both defect. Okay, so we need to get this result. It's 5% plus 5% plus 10% minus 2%. This means 30%. This 30% is the number of items having defect D1 or D2, or it can be both. So the rest 87% of the items are defect free because 30% of the items have either defect D1 or defect D2 or both. So what is the probability that the randomly selected item has neither defect? It's 87%, meaning that 87 over 100, the result is 0.87. So the answer for this problem is D. In how many more ways In how many more ways can 4 people be arranged in a row than if they were arranged in a circle? Here, there is a formula for any arrangement in a row and in a circle. Okay, in a row, n objects can be arranged in n factorial ways. Okay, so in a row, 4 peoples can be arranged. 4 peoples can be arranged in 4 factorial ways. In 4 factorial ways means 4 factorial means 4 times 3 times 2 times 1, which is 24 ways. There are 24 ways of arranging peoples in a row. Whereas in a circle, in a circular manner, n objects can be arranged in n minus 1 factorial ways. Okay, for example, if we want to arrange 4 peoples in a circular manner, 4 peoples can be arranged in 4 minus 1 factorial ways. 4 minus 1 factorial ways means 3 factorial. 3 factorial means 3 times 2 times 1, which is 6. So 4 peoples can be arranged in a circular manner in 6 different ways. In a row, there are 24 different ways. So whenever we arrange peoples in a row, the arrangement will differ by 18. The difference between 24 and 6 is 18. So there are 18 more ways to arrange peoples in a row than when we arrange in a circular manner. So the answer for this problem will be C. A team of 10 researchers consists of 4 biologists. The total number of researchers is 10. In this group, 4 of them are biologists, 6 of them are chemists. If 3 persons are chosen randomly from this 10 group, what is the probability that at least one is biologist? Here, the group is totally, the number of group is 10. Out of this 10 group, we want to select randomly 3 peoples, but during the selection, the question is, what is the probability that at least one is biologist? Okay, out of these 4 biologists, what is the probability of selecting at least one biologist? Meaning that there are 4 biologists in the group. If we want to select at least one, that means we can take 1 biologist or 2 or 3. So if I take 1 biologist from the group, 2 will be from the chemist. There are 6 chemists. The other option is I have the right to take 2 biologists because it says at least 1 biologist. That means I can take 1 or 2 or 3. So if I take 2 biologists, I will take 1 chemist. Okay, I will take 1 chemist. The other thing is if I take all the biologists, that means 3 of them are from biologists. That means I will not take any from chemist. Okay, this is 1 biologist, 2 chemists, or the other option is 2 biologists, 1 chemist. The third option is 3 biologists, no chemist. Okay, these are the mathematical expression of the given statement, but we divide all these things for the total selection. We select 3 out of 10. Okay, so we need to calculate these values. So combination of 4, 1 is 4. You can verify this thing, because combination of 4, 1 means 4 factorial over 4 minus 1 factorial times 1 factorial, which is 4 factorial over 3 factorial. The result is 4. So you can also do the combinations for the rest. Okay, so I will substitute these values here in this. So the probability of selecting at least one biologist from this group is combination of 4, 1 is 4. Combination of 6, 2, you can use the formula, it will be 15, plus combination of 4, 2 means 6, and combination of 6, 1 is also 6, plus combination of 4, 3 is 4, 3 is 4, times combination of 6, 0 is 1, over combination of 10, 3. But what is combination of 10, 3? Combination of 10, 3 means 10 factorial over 10 minus 3 factorial times 3 factorial. This is 10 factorial over 7 factorial times 3 factorial, which is 10 times 9 times 8 times 7 factorial over 7 factorial times 3 factorial is 6. Now we have something that can be cancelled. By 3, 3, by 3, 2, by 2, 4, by 2, 1. So combination of 10, 3 is 120. So here we use 60 plus 36 plus 4 over 120, which is 100 over 120. This can be simplified to 5 over 6. So the probability of selecting at least one biologist from this is 5 over 6. In how many ways can a committee of 3 members be formed from 7 candidates? Totally there are 7 candidates, out of which we are asked to select 3 members, but how many ways do we have to select 3 members from 7 candidates? So here we apply the concept of combination. The total number of candidates is 7. Out of these 7, we want to select 3. So combination of 7, 3 will be the number of ways of selecting 3 committees from 7 members. So this means 7 factorial over 7 minus 3 factorial times 3 factorial. So the result is 7 factorial over 4 factorial times 3 factorial, which is the same as 7 times 6 times 5 times 4 and so on. But I can stop here by on 4 factorial over 4 factorial times 3 factorial. Now this 4 factorial can be eliminated. 3 factorial is the same as 6, so we can write like this. So over 6. Now it remains 7 times 5. 7 times 5 is 35. So there are 35 different ways of 3 members from 7 candidates. Therefore, the answer for this problem is D. A box contains 10 items, of which 3 are defective. That means there is 7 are non-defective. If 2 items are randomly taken out of the box, what is the probability that both are non-defective? So here, the probability of obtaining 1 item which is non-defective is 7 over 10. The probability of obtaining 2 items which are non-defective is 7 over 10 times 7 over 10. So this result is 49 over 100. So this is the probability of obtaining both items which are non-defective. So the answer for this problem is D.